My husband designed the flimsiest hurdle I have ever seen. They're super helpful because they allow me to really attack the hurdle without worrying about hurting myself. Super flimsy, so if I hit it, I can just do that. So it's really helpful, and I'm very excited to continue to train for my third Olympic Games with it.
Hurdles are dangerous, and even pros get mixed up with hurdles in serious races and even in practice, and people have gotten seriously hurt. The issue is that to be as fast as possible, you want to keep your feet on the ground running as long as possible. So they have to get over the hurdle and get their feet back down, get running, get as close to the hurdle, jump over it or step over it, and keep doing that hurdle after hurdle to get the best possible time. However, if you hit the hurdle, it can be seriously dangerous. So it's normal and natural for an athlete to back off the hurdles and not get too close. So the idea was to create a hurdle that wouldn't hurt the athlete, that gives you the feedback of whether it's been hit or not, but without the danger of the athlete potentially getting hurt, giving them the confidence to get closer and be more aggressive. So that's the idea behind the flimsy hurdle. It's designed to collapse, and it utilizes magnets to hold the key parts together. So I designed and utilized 3D printed parts and inexpensive parts that you can get from the local hardware store to create hurdles that were portable and also safe for the athlete to be aggressive and to actually make mistakes with, which is really good for pros trying to fine-tune their races, or even beginners that are uncomfortable with hurdling in the first place and they need to get over that lack of confidence and be able to attack them. So please come with me as I show you how I built these flimsy hurdles. These hurdles have the same sort of parts that a normal hurdle has. You have 2 legs, 1 horizontal cross piece, 2 vertical upright pieces, and then the crossbar. Here, all of the black pieces are printed out of black PETG, and all of the white pieces are PVC pipe. The cross piece, the purplish, is a insulative foam. These joints are connected magnetically so that they can readily fall apart if they're struck. In order to make the assembly as simple as possible, those magnets are actually embedded in the 3D prints, inserted during the printing phase so that they cannot be removed. In order to embed the magnets, a lot of slicers allow you to insert pauses in your print. In Bamboo Slicer, the way that you do this is you add your part, slice it, then move your layer. Remember that the pause occurs at the beginning of the layer, not at the end of the layer. So you find the first layer that is bridging and covering where you want to put in whatever the thing is, in this case a magnet, and then you add the pause at that layer by using the plus sign on the right side here where your layer slider is. Once you have that incorporated into your design, you can send that to the printer, and when it reaches that point, it will pause and you can place in the magnet. One of the key things to be aware of and to be careful of is to make sure that the polarity of your magnet is correct. I like to use the mating part next to it to make sure that the magnet polarity is correct, and then remove the magnet from that mating part, place it into the part, and then continue your print. This part is going to go into that part, and they connect in this orientation. So I know the magnet needs to be in this position. It's going to work. Just pull that off of there, and without changing orientation. Just pull that off of there. Without changing orientation, we put it in there. Now, just to double check, this should repel, and it does. And that's what you want. You want to make sure that that's exactly correct. And then you hit resume on your part. Through the magic of editing, we'll jump forward and not make you wait. As I mentioned before, when you get to a layer and you add the pause, it actually adds the pause at the beginning of the layer, not at the end of the layer. So if you remember in the slicer, we had this bridging layer set up. The pause occurs, and when you resume, it continues on to do the stitching and do that bridging, which locks your piece into the part. So after printing all my parts, the next step was to carefully cut all of the parts to precise sizes. I used my table saw with this crosscut sled. Let me know if you have any interest in seeing a build video on that. You could use a chop saw. There's two issues. One, when you're cutting off a very, very little piece with a chop saw, there's a decent chance that it could get bound and kick. The other thing is it's harder to set an end stop and do repeatable cuts, whereas on a table saw, that's actually quite easy. So in this situation, I chose the table saw. After everything was cut to length, I laid out all of my pieces and then began assembling. First, I assembled the uprights and put a screw in each one so it couldn't be pulled apart, but it could be removed if it was unscrewed. The legs, on the other hand, I glued, and I printed this special funnel to fill the legs full of sand and then glue both ends on to encapsulate that sand. Here I'm using Gorilla Glue, and per the instructions, you always want to wet the mating part when you put it together. It causes it to cure faster, it foams up, and gives you really good adhesion. So after that, it's a matter of doing the same tasks over and over and over again until you have all of the parts to assemble however many hurdles you're making. One thing I learned from model airplanes is always wrap your foam in packing tape. The foam is actually reasonably sturdy if it has that outer skin of packing tape to protect it. And there you have it, a completed hurdle. One of my design considerations was that it could be fit into a piece of luggage so it could be easily taken to the track or brought home for training purposes. So the length of the parts were set along that. Secondly, this is set to the height of women's hurdles because I designed it for my wife. The principal design consideration is the safety of the athlete. That's why I've chosen PVC, which is very light. That's why I've chosen foam for this crossbar. It's held together with magnets, so it holds very well even in a reasonable amount of wind, but as soon as it's struck by a human body, it falls apart. And the hurdle base itself can tip over like a normal hurdle, and since it's lighter, it actually gives more easily. Cindy had this luggage already, and after doing some careful calculations, I figured that I could fit 3 in here, which was the ask. So it might fit 4, I never tried. But the fundamental idea is it's packable. You can break down the hurdles into reasonable pieces. There's no screwing required. You just press them into position, snap the magnets into position, and away you go. And when it's time to leave, you can take the whole thing apart, just pull the pieces out. It packs down very small into a suitcase and easy to take from practice or easy to store into an equipment room. Thanks for watching. I hope that you found this interesting. Even if you weren't here for the track, I hope that you found the engineering and design aspects to be really interesting. For the folks that are here for the track and are perhaps interested in getting a hold of some of these training aids, please check out the pinned comment down below. Leave me a comment and give me some more information about that. Cindy's headed into her 3rd Olympic Games, which is an amazing accomplishment in and of itself. Very few people are blessed enough to be able to compete in 3 consecutive games. I'm incredibly proud of her, of all of her hard work and everything that she has accomplished in the sport. So please join me in supporting Cindy. Go Cindy.
Well, trying to hold off from the inside, Sember, but Sember might get her at the line.
Have a new winner.
Sorry, thinking about it. I'm like, I don't even know how to think about it.
You could well, no, just
First try.
Please check the pinned comment down before below